What if the end of everything isn't really the end at all? Imagine a universe where collapse isn't final, but a doorway to rebirth. A cosmic rebirth powered by the weird, mind-bending principles of quantum physics. Today, we're diving into the provocative idea of the quantum resurrection, where the universe might not just fade away, but rise again in a new form, and what that could mean for everything we know. If the thought of an endless cycle of cosmic renewal sparks your curiosity, stick around. This could change how you see the very nature of existence itself. The concept of the end of the universe. The end of the universe is a subject that has fascinated scientists, philosophers, and science fiction writers alike for centuries. Contemporary cosmology presents several theories about how the cosmos might eventually meet its ultimate fate, each based on different physical principles and observational data. The Big Freeze, or heat death, remains the most widely supported scenario, suggesting that as the universe continues to expand at an accelerating rate, energy becomes more diffuse and stars burn out, leaving the universe cold, dark, and inert. In this scenario, entropy reaches a maximum state, and no thermodynamic free energy remains to sustain processes that we associate with life or complexity. On the other hand, the Big Crunch proposes that gravitational attraction could eventually halt expansion and reverse it, collapsing everything back into an extremely dense state, potentially setting the stage for a cyclical rebirth. Quantum mechanics introduces intriguing possibilities that challenge classical views of the universe's fate. One of these is the theory of the vacuum state, the lowest possible energy state of a field, which might not necessarily be stable. If our current vacuum is only a false vacuum, a more stable vacuum could exist in a different state. A sudden transition to this true vacuum could cause a bubble of changed space-time to expand at the speed of light, destroying everything in its path and fundamentally altering the fabric of reality. This quantum tunneling effect remains speculative, but has the potential to dramatically redefine what we understand about cosmic death and rebirth, opening the door to ideas of multiple universes or phases of cosmic existence. The concept of the universe's end also intersects with ideas about what might follow once the cosmic horizon is reached. Some theorists speculate that as the universe approaches its thermodynamic limit, the quantum realm could come into play, providing mechanisms for a kind of rebirth or revival. This notion ties into the quantum resurrection hypothesis, which suggests that information and quantum states may persist or regenerate in ways not entirely understood within current physics. It implies that what we perceive as an end might not be the final chapter, but rather a transition point. Certain models even entertain cyclical cosmologies, where the universe repeatedly collapses and reemerges, driven by quantum fluctuations or other mechanisms yet to be fully comprehended. Exploring the end of the universe through the lens of quantum mechanics significantly broadens the scope of what's possible. It pushes us beyond classical cosmology into the realm of probabilistic events and hidden dimensions, where the lines between destruction and rebirth blur. Despite our current technological and theoretical limitations, these ideas serve as profound reminders that the universe could have a dynamic, ongoing life cycle far beyond our immediate perception. As science advances, the boundary between an absolute end and a new beginning might become less distinct, fueling speculation about the potential for a quantum resurrection hidden within the fabric of cosmos itself. Quantum foundations and multiverse theories. Quantum foundations explore the fundamental nature of reality, emphasizing how the peculiarities of quantum mechanics challenge classical notions. At its core, theories like wave-particle duality and superposition suggest that particles can exist in multiple states simultaneously before being observed. This intrinsic indeterminacy sparks debates about the true fabric of the universe. For example, in the Copenhagen interpretation, the act of measurement collapses a quantum wave function into a definite state, implying that reality remains fundamentally probabilistic until observed. Conversely, pilot wave theory posits that particles have definite trajectories guided by a hidden wave, offering an alternative picture that preserves determinism but introduces non-locality. Expanding from these puzzles, multiverse theories propose that our universe might be only one among countless others, a sprawling, interconnected landscape of realities. The many-worlds interpretation, in particular, suggests that every quantum event causes a split, giving rise to separate, non-communicating branches. When a measurement occurs, the universe bifurcates, creating multiple versions of reality that coexist. This view bypasses the collapse problem by allowing all possibilities to be realized somewhere. For instance, in hypothetical experiments involving Schrödinger's cat, the cat is both alive and dead in the multiverse, with each outcome existing in a different branch. While this idea is difficult to test directly, it provides a compelling way to reconcile quantum mechanics' weirdness with a consistent, if surreal, cosmology. Recent advances in quantum technologies have begun to lend weight to multiverse notions indirectly. Quantum computing, for example, leverages superposition and entanglement to perform calculations that seem to explore multiple possibilities simultaneously. Theoretical physicists argue that the bizarre phenomena observed at the quantum scale could hint at deeper multiversal structures, where each entangled state connects distant parts of the cosmos across different realities. Some speculate that the universe's apparent fine-tuning and the presence of multiple constants could be explained through a kind of cosmic selection process across a multiverse, where countless universes with varying physical laws exist, but only some support life and consciousness as we know it. In broader philosophical terms, these ideas intensify debates about the nature of existence and the possibility of a post-quantum or post-multiversal reality, what some might call the resurrection after the end of everything. If our universe, or even reality itself, arises from a multiversal tapestry, then understanding the quantum underpinnings becomes not just a scientific pursuit, but a quest to glimpse the very architecture of multiple, intertwining existences. Could the ultimate resurrection stem from a quantum or multiversal rebirth, a process where shattered realities recombine or reemerge in new, unexpected forms? That remains an open question, endlessly fueling both scientific curiosity and imaginative speculation. Mechanisms for cosmic rebirth. The idea of cosmic rebirth often hinges on the concept that the universe might undergo cycles of expansion, contraction, and renewal, governed by complex physical principles that transcend our current understanding. One prevailing theory suggests that after a universe reaches a point of maximum expansion, gravity could eventually pull all matter back together, initiating a contraction phase known as the Big Crunch. This process might set the stage for a new Big Bang, igniting a fresh universe from the remnants of the previous one. In this scenario, the fabric of space-time itself could collapse to an incredibly dense state, where quantum effects overwhelm classical physics, forcing a transformation into a new state of existence. Quantum mechanics offers intriguing mechanisms for this rebirth. Vacuum fluctuations, which are temporary changes in energy levels of empty space, could potentially trigger phase transitions in the fabric of spacetime. These sudden shifts might cause a quantum tunneling event, a process where the universe transitions from one stable state to another without passing through intermediate phases. Theoretically, such tunneling could manifest as a bubble of new, expanding spacetime forming inside a contracting universe. As this bubble grows, it could effectively replace the old universe, giving rise to a new cosmic cycle. This process echoes certain models in quantum field theory, where multiple vacuum states exist, and the universe can jump between them under certain conditions. Another mechanism involves the notion of bounce cosmology, where instead of a catastrophic collapse, contraction halts at a minimum scale due to quantum gravitational effects. These effects, predicted by advanced theories like loop quantum gravity, suggest that the universe's density cannot reach infinity. Instead, quantum repulsion at extremely small scales causes the universe to rebound, an incredibly rapid and energetic rebound, creating conditions similar to a new Big Bang. This bounce would be smooth rather than violent, with quantum fluctuations influencing the properties of the new universe, potentially imprinting subtle signatures observable today in the cosmic microwave background. Finally, some hypotheses entertain the idea of multiversal pathways, where our universe's end might connect to a broader cosmic ensemble. In this view, cosmic rebirth occurs within a larger multiverse framework, where individual universes are like bubbles in a vast cosmic foam. When one bubble collapses or reaches a terminal point, quantum mechanics could allow a new universe to nucleate from the remnants or from fluctuations within the multiversal space. These processes are heavily theoretical but open fascinating possibilities for understanding cosmic rebirth, where the death of one universe doesn't mean the absolute end, but rather a transition into a new phase of existence, driven by the inherent properties of quantum fields and the structure of spacetime itself. Implications and philosophical perspectives. The concept of a quantum resurrection ventures into the realm of speculative physics and metaphysics, suggesting that in some form, existence could be reborn or reconstructed after an apocalyptic event or even the cessation of the universe itself. At its core, this idea hinges on the principles of quantum mechanics, particularly the notion that particles exist in superpositions and that observation can influence reality. If the universe operates in accordance with multiversal or many-worlds interpretations, then every possible outcome, including the continuation or rebirth of consciousness, might persist across different branches. This leads to a mind-bending question. Could consciousness somehow tap into these quantum states to survive or re-emerge after a collapse? Philosophically, such a scenario raises profound questions about identity, consciousness, and the nature of reality. If a form of resurrection is theoretically possible through quantum principles, does that mean our sense of self is fragmented across multiple timelines or worlds? It also prompts debates on whether continuity of memory and experience is necessary for true revival. For instance, in some interpretations, a resurrected version of oneself might only be a clone or an identical replica, rather than the original consciousness. This distinction matters because it challenges traditional notions of personal identity. If the quantum resurrection involves copying, then what does it mean for authenticity? Are we truly resurrected, or simply replaced with a perfect simulation? From an implication standpoint, embracing quantum resurrection could revolutionize our understanding of death and existence. It might lead some to argue that death is not an absolute end, but a transition into different quantum states that preserve consciousness in some form. This idea aligns with certain interpretations in quantum consciousness theories, which suggest that the mind is inherently quantum in nature, and thus capable of bridging the divide between life and what comes after. However, skeptics point out that our current understanding of quantum physics and consciousness remains incomplete, and applying these theories to large-scale phenomena like the universe or individual death pushes the boundaries of scientific credibility. Nonetheless, contemplating these notions fuels philosophical debates about the ultimate fate of consciousness and whether our sense of self can survive beyond the limitations of physical mortality. Ethically and practically, if quantum resurrection became a reality or a plausible theoretical framework, society would need to confront new moral dilemmas. Would resurrected entities have rights or personhood status? What conditions would enable or prohibit resurrection? Could it be weaponized or exploited for personal gain? These questions highlight how deeply intertwined metaphysical speculation becomes with tangible societal concerns. The philosophical perspectives on the quantum resurrection challenge age-old assumptions and inspire rich dialogue about what it means to be alive, to die, and ultimately, whether a form of eternal recurrence might be woven into the fabric of reality itself. Usnovnoy, Rusgil 5. The concept of a potential resurrection after the end of everything often hinges on the principles of quantum mechanics and the multiverse theory. Some interpretations suggest that every possible outcome of every event spawns its own universe, creating an infinite ocean of realities. In this framework, the notion of destruction or finality in one universe doesn't necessarily mean the absolute end. Other branches might continue unaffected or even give rise to new beginnings. Essentially, the idea isn't about a resurrection in traditional terms, but more about the persistence of consciousness or information across a vast array of alternate realities. One of the core ideas informing this section relates to quantum decoherence and how the collapse of a wave function can be viewed as a transition between different states. If the universe operates on a multiversal scale, then the end of one universe could correspond to a phase shift rather than an absolute cessation. In certain speculative models, Quantum information isn't destroyed but stored in a higher dimensional space, sometimes called the quantum foam or the holographic universe. When conditions change, say, through cosmic inflation or a resolution of singularities, this stored information might be rebound or reconfigured, allowing for a form of rebirth or rebirth-like event. An example of this can be seen in black hole physics. Some theories propose that the information paradox, how information seemingly vanishes into a black hole, could be resolved through quantum entanglement and holography. If this holds true, then the destruction of matter in a black hole doesn't mean complete annihilation, but rather a transfer or encoding of that information into a different state, potentially retrievable or reconstituted later. Extending this notion to the universe as a whole opens up spectacular possibilities. Perhaps the end of one universe doesn't mean permanent death, but rather a transformation or a gateway to a new or existing state, echoing ideas found in some interpretations of the cyclic universe hypothesis. In practical terms, discussions about cosmic rebirth often delve into the concept of bounce cosmology and the cyclical universe models. These theories propose that the universe undergoes endless cycles of expansion and contraction. After a big crunch, for instance, cosmic forces could trigger a new Big Bang, effectively wiping the slate clean but retaining some quantum imprint of the previous cycle. In these models, the resurrection is not so much an act of rebirth as it is a natural consequence of the universe's eternal rhythm. While still speculative and heavily debated among physicists, such models challenge linear notions of finality and inject a sense of continuity that could encompass even the ultimate end of everything. As we wrap up this journey through the quantum resurrection, it's clear that the universe may hold hidden possibilities beyond our current understanding, where even after the end, there could be a new beginning rooted in quantum mechanics and cosmic cycles. We've explored the intriguing idea that consciousness, matter, and energy might be interconnected in ways that allow for rebirth on a scale we're only beginning to grasp, leaving us to wonder what lies beyond the observable horizon. Thanks for sharing this moment with me. First, hope it sparks your curiosity and prompts you to ponder the boundless mysteries waiting just beyond our reach. If this video resonated with you, don't forget to like, subscribe, and stay tuned for more deep dives into the universe's greatest enigmas. There's so much more on the horizon, and First can't wait to explore it with you. Until then, keep questioning, keep dreaming, and stay curious about what's next.